Alright, so today's video is inverse functions. We've been talking about functions a lot, and tonight we're going to talk about inverse functions. Okay? This is section 1.9 in your book, and this is the best artwork I've had yet in these videos. Pretty solid right there. Okay. So what are we going to talk about tonight? Well, first, what is an inverse function? How to find the inverse of a function, how to verify the inverse of a function, and what does an inverse function look like? What does the graph look like? Okay? Well, what is an inverse function? If we define f of x to be the set of ordered pairs 1, 2, 3, 4, 5, 6, 7, 8, the inverse of f of x, which is called, well, basically this is the notation. This is the inverse of f of x. That's how you write it right there. Will be represented by the set of ordered pairs 2, 1, 4, 3, 6, 5, and 8, 7. So all we did there was literally switch the x and the y values, right? Here we had 1, 2, now we have 2, 1. Here we have 3, 4, now we have 4, 3. Alright, and I know what you're thinking right now. Mr. Harrigan, what does this mean? Alright, well, let's go back way to the beginning. When we were talking about functions for the first time, we had a function where you could plug in a time of day, an AM, and it would tell you the temperature. Alright, so that's the function. You'd plug in a value for time, and you'd get the temperature. The inverse of that function, you would plug in the temperature, and it would tell you the time of day. So it's kind of the opposite. Right? Okay. So how do we find the inverse of a function? Well, we take f of x equals 2x minus 3, write it as y equals 2x minus 3, we switch the x and the y, and then we solve for y. So I went through and I solved for y, and I got this right here, and then that is going to be the inverse. So if f of x equals 2x minus 3, the inverse of f of x equals x over 2 plus 3 halves. Alright? Let's do another example. So, we write it as y equals square root of x. We switch the x and the y. And we solve for y. So here, we're just going to square both sides. And we get y equals x squared. So, the inverse of x is going to be x squared. Alright? So here's kind of an example of what an inverse function does. In the original function f of x, we plug in 4, so f of 4. What are we going to get? Well, we're going to plug in 4 for x. We're going to get the square root of 4. We're going to get 2. Now, for the inverse of x, if we plug in 2, what do we get? We get 2 squared, which is 4. So here we plugged in a value, and we got 2. Well, the inverse says, well, plug in that value, and I'll tell you that it's 4. Switches it. Alright, so one more example. Alright, as y equals 4 minus 3x over 5. Switch the x and the y. And multiply both sides by 5, so we get 5x equals 4 minus 3y. I'm going to add 3y to both sides and subtract 5x from both sides. So I'm going to bring 3y over here. And bring 5x over. And then we're going to divide the whole thing by 3. So y equals 4 minus 5x divided by 3. Alright, so the inverse of x, f of x, whoa, rear, undo that, Kevin, you're an idiot. Alright, there we go. The inverse of f of x is going to be equal to 4 minus 5x over 3. Right? Alright, so basically what you can see is going to happen is if you take the inverse of a function and plug it into the original function, you're going to get x. Or if you plug the original function into the inverse of the function, you're also going to get x. And we're going to show what that means exactly right here. So, we have f of x. We know that the inverse is going to be x over 3. Let's just do that real fast. We're going to have y equals 3x. We switch to x and y. And we find that y equals x over 3. So that's what I have here. If we take f of g of x, which we were doing today in class, that's going to be this plugged in for x. So we're going to have 3 times x over 3, which is simply x. So that's what I mean. If you plug the inverse in for x, you're going to get just x. Okay? Or, if you plug in f of x, the original function, for g of x, you're going to get x as well, because that's going to be 3x over 3. 3x plugged in for 3x, it's going to be 3x over 3, which is just equal to x. I'll show you another example. Remember, you can always pause these and go back. Alright, if this is f of x, you can see that we solve for the inverse easy here. We're going to switch the x and the y. I'm going to add 4 to both sides. It's going to be y equals x plus 4. Alright, that's what we have here. So, if we plug in, if we solve for f of g of x, or g of x is the inverse of f of x, we're going to get this whole thing plugged in for x, so it's going to be x plus 4 minus 4, which is equal to x. Or we're taking g of f of x, it's going to be this plugged in here for x, and this is going to be x minus 4 plus 4, which is also x. Alright, so if you plug an inverse into the original function, you're going to get x. If you plug the original function into the inverse, you're going to get x. That's what inverses do. Alright, again, let's plug g of x into f of x. What's going to happen here? It's going to be 3 times 2x plus 2. Well, look at this. This is equal to 6x plus 2. So this must not be the inverse. And let's check it out. Alright, if we have y equals 3x plus 2, we're going to switch the x's and y's. Alright, we're going to subtract 2 from both sides. It's going to be x minus 2 equals 3y. Come down here. So I'm just going to rewrite that. 3y equals x minus 2. Divide both sides by 3. And we see it's x minus 2 over 3. So this is the actual inverse of f of x. Okay? This is not the inverse. And that's why when I plugged this into that, we did not get x. We got 6x plus 2. I just wanted to show you how it didn't work. So before, for these, we were verifying if it was inverse, and yeah, we verified it. We got x. So this is an inverse of this. Here, well, we tried verifying, but we verified that it wasn't. Okay? Last topic here, the inverse graph. What happens if you have a function, the inverse of the function is going to be reflected across the line y equals x. Alright, so we've been talking about reflections across the y-axis and across the x-axis, but now we're going to reflect it across y equals x, this line right here. Let's show a couple examples. Alright, so blue is your original function. The red graph is the inverse. Everything gets flipped right across that line. Okay? Again, f of x equals x squared is in black. Reflecting across here, we find the function in red. And here's the last thing I'm going to touch on here. For f of x, we know we have these points, right? You plug in -1, you're going to get 1. You plug in 1, you're going to get 1. Right? These are these 2 points right here. You plug in -2, you're going to get 4. Right? You plug in 2, you're going to get 4. Right? And so on for 3's. Now, the inverse function, what did we do before? The very first thing, we flipped these points, right? That's why we get 1, comma -1, 1, 1. Instead of -2, comma 4, we're going to get 4, comma -2. Instead of 2, comma 4, we're going to get 4, comma 2. Well, let's examine this real fast. The inverse of f(x) is not a function. We can see that because it does not pass the vertical line test. And we could have easily seen that because from the beginning, this has -1 going to 1, and it has 1 going to 1. So then when we flip these points, 1 goes to -1, and 1 goes to 1. Alright? Keep that in mind. We're going to touch base on that a little bit more in class. Alright? Question time. Oh, stop it!